All right, so let's take up this simple problem. We are required to find the value of x from this given equation. So let me read this once. So twice of x raised to power log of 3 base 4 plus 3 raised to power log of x base 4. This is given to be 27. We need to pull out this x. So when posed in this way, it looks a bit funny because here x is present at the base and here x is present as the input of logarithm. But the good thing here is that we recall one property that we have seen. Let me quote it once again here. So if you remember that one thing we discussed was that if I have log of x base b and I have b raised to power this whole thing, b raised to power this, then these two things, they cancel out each other and we are just left with x. I think we call this cancellation property. So this is cancellation property. And this happens just because logarithm is an inverse function of exponential function. So whenever the bases they match, then these functions which are inverse of each other, they cancel out the effect. So that's why it's called cancellation property. But here, this won't work because this is 3 and this is 4, so I can't cancel out. So this, and here also we don't know, x is unknown, so we cannot cancel out with 4. So this won't work, but still we have another thing that we discussed, I think we called it exchange property, which talks about when this thing doesn't happen, when these bases don't match, then what to do? Then at least we can do something, and that is that if I have this thing where A and B may be distinct, then we can't cancel out, obviously, but at least we can do one thing wherein we'll hold this B and we can exchange this A and C. So that's the property. That's why it's called exchange property. So this is going to be C raised to power log of A to the base B. So this B remains at its position and A and C have been exchanged. So this is the property that we are going to use here, and that will solve our problem. So let's invoke this thing, let's say on this expression. So I will exchange this x and 3, holding back the base 4. So this is going to be 2x raised to power log of 3 base 4 plus x raised to power log of 3 base 4. So I have exchanged 3 and x, and that is 27. Now since these two expressions, they are same, I can add them up. So this gives me 3 times x raised to power log of 3 base 4. This is 27, and that just means x raised to power log 3 base 4 is going to be 9, and let me write 9 as 3 square. And now we see that here this side the base is 3, at this point the base is x, so we want to exchange this back so that 3 comes at the base. So I'm again invoking this property at this step, and thereby I get 3 raised to power log x base 4, that is going to be 3 raised to power 2. Now this is an exponential equation wherein we are just saying that 3 raised to power this power is equal to 3 raised to power this power. So henceforth we get log x base 4 is equal to 2 because bases match, so powers should be same. And now we can use the definition of logarithms, or to remove this logarithm. So what we want is to remove this logarithm of base 4s because we want to pull out x. So we'll just use of this property now, this one. If we have this bb, they will cancel out. So we will apply base 4 both the sides. So 4 raised to power log x base 4 is equal to 4 raised to power 2. So let me repeat it here. I have used 4 base here. So I have just applied 4 base both the sides. And now this will cancel out. So I'm left with x. And that gives me 4 power 2, which is 16. So that should be the value of x which will fit in this equation. So this gives us the answer to this problem. Very simple problem. So this just gives us an idea of how to use these basic properties. So let me recall once again. To work with logarithms, we only have a very short range of properties. Yeah, so these are the properties that we have seen already. So we just have to keep in mind these things, which just follow from the definition of logarithms. So nothing much to remember here. So the power rule, wherein power comes outside, log of b base b is 1 and log of 1 is always 0. Then comes the product rule, where product of inputs opens up as the sum of outputs. Quotient rule, where the quotient of inputs opens up as the difference of outputs. And then we talked about this, the cancellation property, and if these two are distinct, then at least they can be exchanged. That's the exchange property. And that's it. So using these few tools, we have solved some problems. So we have used these properties in a very fun way. So we'll keep on doing this unless we get comfortable with this. Well, this finishes off this problem. See you in the next one. Bye bye.